Okay, this is actually a continuation of the last video which got cut off. But just to remind you, we already found the Jordan normal forms of our matrix A and B. Let me remind you what A is. A is like a matrix that looks like this with zeros everywhere else. So 1, 2, 3 just above the diagonal. B has ones just below the diagonal, like that. Okay, and we're trying to find, we already showed that the Jordan normal forms are the same, this matrix, but now we want to find, we're going to prove that their Jordan normal forms are equal to this by finding P, such that P inverse AP equals J, and Q inverse BQ equals J, right? Okay, and then that means we need to solve AP equals P times J4, and the ith column of AP is just, or sorry, the ith column of AP is just A times VI. The columns of P are V1 up to V4. And the ith column of P times J4 is just one of these columns times P. So the first column of PJ4 is 0. The second column is the first column of P, right? And so on. So we have, so we have the equation AV1 equals 0, AV2, second column of PJ is first column of P, which is V1, AV3 is V2, AV4 is V3, right? And we want to find V1 up to V4 satisfying these equations for A. So let's just try, well, V1, that's going to be in the null space of A, so let's just try 1, 0, 0, 0. And now let's try and find a V2 such that V2 equals V1. I'll just try 0, a half, 0, 0. Now multiply by A. No, actually we can just do 1, sorry. So now do A times V2, we get 1, 0, 0, 0. So AV2 equals V1. Now we want AV3 to be V2. Now let's put a question mark there. And whatever is here, when we multiply it by A, we'll get 0, 2 times our question mark, 0, 0. And we want 2 times the question mark to be 1, so this is where we put that 1/2. And let's put, similarly, put a third for V4. Actually, no, we would need a 1/6, yes. Okay, now let's check A times V4. Well, it's just 0, 1, 0, 0, 0, 0, 2, 0, 0, 0, 0, 3, 0, 0, 0, 0, and V4 is 0, 0, 0, 1/6. Okay, so when I take this column and multiply it to the first row, I get 0. This column times the second row gives me 0. This column times the third row gives me 0, 0, 0 plus 3/6. So it gives me a half. And then this column times the last row is 0. Okay, in other words, I get V3. And when I do AV3, well, I'll just rewrite V3, and okay, when I do A times V3, this times this, right, I get this times the first row is 0. This times the second row is 0 plus 0 plus 2 times a half plus 0. That's 1. 2 times a half is 1, and then the rest are zeros. This is just V2, and now AV2 is also equal to V1, and AV1 equals 0. Okay. That tells me now that we should take P to be V1, V2, V3, V4 as its columns. So 1, 1, 1/2, 1/6, and zeros everywhere else. And of course, P inverse is just 1, 1, 2, 6, zeros everywhere else. Okay. Okay. And let's do, like, as an exercise, let's try for B. Remember, B is like a transpose of a Jordan block. Okay. And we want to find BV1 equals 0. We want to find BV2 equals V1. We want to find BV3 equals V2. And BV4 equals V3. Okay, so BV1 equals 0. Well, we'll take V1. We'll take V1 to be 0, 0, 0, 1. Okay. Now we want to find a V2 such that BV2 equals V1. Okay. So how do we find a V2? Well, remember, B x1, x2, x3, x4, that's just 0, x1, x2, x3. We want this to be 0, 0, 0, 1. So x4 kind of doesn't matter, it can be anything, but x3 has to be equal to 1. So, and x1 and x2 have to be 0. So it'll take V2 to be 0, 0, 1. And then actually, I'll put a 0 here, but it could be whatever. But we'll put a 0. And that's V2. And now I want to make B times x1, x2, x3, x4 to be V2. So I want it to be 0, 0, 1, 0. So again, x4 doesn't matter, but x3 has to be 0, x1 has to be 0, and x2 has to be 1. So now V3 has to be 0, 1, 0, 0. And again, this could be something else, that's fine. Okay, and then finally we'll take V4. We want B times V4, this is V4, to be 0, 1, 0, 0. Well, x2 and x3 has to be 0, and x1 has to be 1, and x4 can be anything. So this will be 1, 0, 0, 0. Right? And so in all, our matrix Q is this matrix. Kind of like a diagonal matrix, but going the wrong way, or something like that. Okay. I think Q inverse is just Q, I think. Yeah, and then you can check that. Q inverse BQ is therefore J. Okay. And let's stop for now.